Everybody, welcome back. This is Graduate Statistics Week 3. I promise this is the last video for today. We have just been going over the regression equations that have been generated for I-79 equals 0 for cows with less than 79 days since lactation and for those with more than 79 days. And we saw that in our final model, we're letting both intercept and slope vary because it's useful to do so, given what we saw in our model in terms of hypothesis test. Now let's make the plot with the two different colors for the two different levels of I-79, but now let's fit a line in each one of them. And for that, I'm using this function geom_smooth. You've seen that before as well in previous labs, and I'm using the linear model. I'm asking R to fit a line for each one of the levels. And if I run this, it didn't run this time. I have no idea why. Oh, I know. This, and it's previous milk. No, previous and current milk. Now it might work. It's extremely slow. I don't know what's going on with my RStudio today. All right, so here is the line for level 0 of I-79. That's cows that have not been lactating for long. So let's see if that matches up our equation. You have a higher intercept, so higher values of current milk production than what is observed for cows with longer time lactating, when values of previous milk production is kind of low. When you have lower values of milk production last month, then you're going to be better off to have cows that are just recently lactating in order to improve your milk production this month. But if previous month was good, then it doesn't matter what cows you have, right? Then it's not really critical, okay? So the differences kind of disappear. So you start out better if you have less time lactating, for lower values of milk production, because the intercepts differ with higher intercept for when I-79 equals 0, but then the slope is higher, steeper for when I-79 equals 1. Basically twice as steep as this. That's what our equation says, right? So lower intercept when I-79 equals 1, that matches up. It starts out lower, but you have a steeper line here than here, such that when you have higher values for milk production, you may actually be better off with older cows. But the difference seems to sort of disappear. You can see how the confidence intervals begin to kind of merge together. They seem to be pretty separate down here, but merging together right there. All right. So now let's make some predictions to really drive this point home, and then you guys can go and start thinking about how you're going to write a report to your boss that you're trying to organize things in the farm. So you think it's really important to know what current production is and try to do stuff to improve that current production, given what you know about previous production and what the lactation looks like this month and the lactation time looks like this month. So you're going to have to write a report and use these plots to illustrate your findings. All right. Okay. So let's select two specific cases and make predictions. Use values. We have to use values in the range of data. We're going to choose cases to illustrate some point that we want to make. And the point that I want to make to you is that the impact of previous milk production will depend on whether the cows that you have, that you're dealing with in that month, whether they have been lactating for less or more than 79 days. right? If you have a high milk production on the previous month, it won't matter much if you have cows that have been lactating for long or for a small amount of time, right? But when you have a low milk production, let's say in August, and you look forward and you say, oh my gosh, all the cows have been lactating for a long time, that lower milk production will tend to be forecasting a very dark month the following month. But if you have in 1 month low milk production, but cows are just beginning to lactate, that won't be that dramatic, right? You shouldn't expect a huge drop in the following month because the slope will be less in that month. But let's see how that shows up in terms of predictions. So we're going to imagine a month with low, where the previous month had a very low production, about 20 pounds of milk, right? So you can see how this will not be so much of a problem. The following month will have quite a bit of production regardless. If cows have been lactating not for too long, less than 79 days, if I79 equals 0. But if you have this low production in 1 month, then you would predict pretty low production also in the next month. If you look at the cows like, oh my gosh, they're all towards the end of their lactation, this will tend to have a greater impact on those months, so you can plan ahead. So you want to make that case to your boss. So let's make predictions for these cases when previous month was really bad, 20 pounds, and we're looking at the number of days after lactation equals 0 and 1 and make predictions. What will be the current production given that last month was 20 pounds and our cows, if the cows have been just beginning to lactate, and whether they have been lactating for more than 79 days. And we'll do the same forecast for when previous milk production was 100 pounds, and now I want to know what's going to be my current one. If my cows have been lactating for a short period of time and for long periods of time. We expect the predictions A1 and A2 to differ a lot, and B1 and B2 not to differ so much. Look, for 20, we expect predictions in A1 and A2 to differ a lot. For 100, we actually expect A1 to be just slightly higher than B2 to be just slightly higher than B1. So instead of doing this by hand, by plugging numbers in the equations, I'll use a function called predict. But for that, we have to set data frames with each one of the cases that will serve as input to that function. So for case A1, previous milk production was 20, and I79 equals 0, right? That's our A1. 20 pounds, and I79 equals to 0. For A2, 20, but you have cows that have been producing for a long time. We expect that the prediction here for case 1 to be higher milk production for current than A2. For B1 and B2, as I said, when previous is 100, we won't expect much of a difference. So let's load that. So we have all 4 cases. Now we're going to do the predictions. So all we need to do is say, hey, make a prediction. Let's store the prediction at prediction for A1. Run the predict function, which takes as input the model, and the model is milk data. That's the model you ran right here, and we kept it, right? Milk model that has the main effect and the interaction. So that's the last one we ran. So it's here. And then I want to see the prediction for case 1. Then I do the same. I'm just naming it differently. I want prediction for case A2. I'm calling it pred A2. You can call it whatever you want on this side. Just call something that makes sense to you. And then all I'm changing is the case that I'm passing. I'm giving previous 20 and I79 1. And I'm putting this in quotes because this is a categorical variable. So this is counting as kind of a string, a name. So if I put just 0, it will get confused because it doesn't expect a number for this variable. It expects a name. We're just naming it 0. Same thing for B1 and B2. And now I'm asking R to print those predictions. Let's see if it happens as expected. So if milk production last month was 20 and my cows have been lactating just for a wee bit of time, less than 79 days, my current production will be 42. Give or take, right? There will be, it's not perfect. It only explains 65% of the variance, but that's your best guess. If your milk production last month was 20 and your cows have been lactating for a longer time, you would expect a greater drop, right, in production. You'd expect less of a change in production. But look, when we're predicting current milk production based on previous milk production, and previous milk production was awesome, the difference between having cows with low time lactating or high time lactating is much less pronounced, right? One is not double of the other anymore. They're pretty much close together, right? With a net advantage to cows that are more time lactating, right? So because the slope keeps increasing, it eventually crosses, right? It continues to increase more for cows that have been lactating for longer. But I wanted to highlight that if previous month production was bad, this tends to continue to be kind of bad in the current month if you have cows that have been lactating for long, but the impact tend not to be bad. You actually would expect to increase if your cows were lactating for just a wee bit of time. If you have good production previous month, you tend to be good production this month too, like high production for both with very little difference between the two. If you want to get a confidence interval of 95% around your predictions, you can use the same function predict using the name of the model, your case object that the object is storing the values of the predictors, and then you say I want an interval for the prediction and I want a 95% confidence. So you can see that for when previous month was 20, you can expect with 95% confidence for current month to be somewhere between 33 and 79. If your cows have been lactating just for a little bit of time, less than 79 days. But if your cows have been lactating for a long time and your previous milk production was just 20 pounds, the current month can be pretty bad, from 3 pounds all the way up to 46. So there's more variability there that can be expected. And then again here, the confidence interval, which seems to be pretty close together, again, pretty overlapping for when previous milk production was high, right? This is the point estimate, and this is the confidence interval for the predictions. And as I said, you have pretty separate confidence intervals here, but overlapping confidence intervals up there. All right. So this is pretty much it for today. The only additional thing I want to show you is that, let's say when you're writing your report, you decide to use this figure, to plot this figure, to put this figure in there. Oh, let me put the Team Classic here, sorry. I was thinking it was looking a little wobbly. If you want to put this plot there, what you can do is right-click, and then you can either save the image to your desktop, and then you can say, oh, I want to save it as figure. And then if you're doing your if you're working on your document, say I'm gonna report predicting current milk production. The idea is to make it not only, the idea is to make this report not only accurate, but beautiful, beautiful presentation, right? Remember, you're trying to tell your boss what you found out. You're trying to show off your work. Do it the best way you can, right? So you're going to talk about what data you have used, what variables you decided to use as predictors, and why. So you can say, oh, we found two variables that seem to be strongly correlated with current milk production. This variable and this variable, those are easy to measure, easy for us to make a forecast of what's going to happen this month based on what happened previous month and how much time the cows are lactating. You just need to keep track of these two things. So you have to justify and then present the results. Say, what did you find, right? In lay terms, right? In the context of the problem. No p-value, no, nothing like that. You will know only to report predictors that are statistically significant. But your boss just wants to know, what is your interpretation? What can I expect to predict given what I see before for the different types of lactation? So if you want to use this plot to ground your explanation, you can. So you can either, like I said, save it, and then you can insert picture from file. So if you saved it on a desktop, I saved the figure here. You can insert, as you typically do, insert figures in Word, or you can, right-click here, right-click on the figure. If you're a Mac user, you do Control-click. Then you can copy image. And when you're here, you can paste special as picture. And then it gets there as well, right? Then you can play around with size, as you probably know how to do it in a Word document. All right? So I want you to try your best. You're not going to lose points for because you didn't do a particular thing. We're just looking for a coherent interpretation and an attempt to make it easily understandable to a person that does not know statistics. Your role is to be the bridge between a data analyst and your boss because of what you know about statistics. How can you translate data findings to your boss to solve a practical problem? Okay? All right, this is it. I'll talk to you Wednesday. If you have any questions, I'll be there as usual at 11. I missed my usual folks this Wednesday, but then I realized it was a holiday, so I thought maybe that's why they didn't come. But I'll be there again at 11 this week. Please let me know if you need anything. Dalton and I will be available to help. All right. See you then. Bye-bye.